Hi, and welcome to this lecture. I want to go over the test on this lecture that we had. So we're going to start with problem number one. Problem number one, you're given this matrix, which has 2 rows and 4 columns. And it's asking you, actually, the first 3 problems is based on this matrix, and it's asking you information based on commands that you will enter. And so on this particular one, it says that, what will be displayed if you type this command. Now, keep in mind that typing those commands is not going to change the contents of the matrix. The matrix remains the same. It's just the information you're going to see is based on the commands. So on this one, this particular one, you have all the rows in columns 1 through 3, right? So in essence, you're gonna exclude the last column of this matrix by just performing this command. It's basically just ignoring the last column because you're looking at all the rows and the columns 1 through 3. So what you will see is this. And by the way, as you notice, the 2 B and C answers are the same. So whether you chose B or C, you will get credit for that problem. The second one is similar, and you have the same matrix, but this time you're defining the elements that you want. And if you remember, this is actually selecting the second row and the second row, right? So you have 2 rows in all columns. And so what you're basically doing is just replicating the last row here, 15.5 and minus 1, 2 times, right? Placing it for each of the rows now. And so you will see this information here. The third one is basically the same. It's just that it's sort of the opposite, because now they're telling you what is being displayed, and it's asking what will be the command that will give you that information. Similar to the other one, right? You have, in this first case, you'll see that you have the second row, the first row, and the second row element. So you'll see 15, 2, and 5, right? Because that's the second row. The second row repeats here, and then you have the first row element here, which is 2. And then for the second part of that matrix, you'll have the first row here, which will be, put in this location. And the second one, which will replace this by 0.5, 50, and 0.5, which is the location of this column right here, right? The fourth problem has a small piece of code. Again, it's the same matrix, but it's asking you to find the value of y after executing the statements. You notice here that there's an index that goes from 1 to 4. Y starts at 2. And if you notice here, it's only looking at the second row of the matrix, right? Because it's only looking at 2, either 2, 1, 2, 2, 2, 3, or 2, 4, which then tells you that it's just looking at the second row of the matrix. So this piece of code is ignoring the first row, but it's just looking at the second row, and it's looking for elements that are less than 2 in that row. And when it finds elements that are less than 2 in that row, it's going to perform this operation here, which is basically going to add the original content of y, which is 2, plus the value that it's going to find as it goes through the rows, right? So looking at the matrix again, you notice that, of course, you have numbers less than 2 are 0.5, minus 1, and minus 3. So those are the numbers that it's going to use. So it starts at 2, right? And then it's updated at every iteration. So in the first iteration, it's going to take 0.5, and it's going to add 2 plus 0.5. So the first iteration gives you 2.5. The second one is going to take the value of y, the computer previously, and add minus 1. So now you're going to have 2.5 plus minus 1 gives you 1.5. So now the value of y is 1.5, and then it's going to add the third element, which is -3, and 1.5 plus -3 will then give you -1.5, which is the answer. The next problem says if x is equal to 1, 3 minus 2, and y is equal to 2, 5 minus 2, what is the value of z after we perform this operation? Well, as you can see here, this first element here, or this first elements here, x1, 2, it means that it's just looking at the elements in x in first and second element, because it's a 1 by 3 matrix. So it's looking at the first element and the second element, which will be 1, 3. And then putting next to that will be the element x1, which is, again, equal to 1. So the first set of brackets here will give you 1, 3, 1. And then the other one is concatenating that with the matrix y, and the matrix y is 2, 5, and -2. So you see this here. Okay. The next one says, what is the output of this code? Well, I guess the key to this problem is to realize or remember from your mathematical courses that when you plot a circle, each component in x represents the cosine of a triangle, and each element in y represents the sine of a triangle, right? So you get a rectangular coordinate equal to xy that determines the point in the circle. So x represents the y component and y represents the y component. So plotting x against y will simply plot every single point along a circle. And multiplying that by 5 will simply expand the radius of the circuit by that amount. In this case, it expands the radius of the circuit by 5. And adding 2 to the x-axis and and 3 to the y-axis, it simply moves the center to 2 and 3, and that's why you will see a circle of radius 5 with center 2 and 3 by plotting each of those points, x and y. The next one says, which statement correctly defines an anonymous function of name cube that calculates the cube of an input argument x? Well, by process of elimination, of course, the answer here is indicated, but I'm going to go through the ones that are not correct. And the first one here is, of course, incorrect because the at symbol is in the wrong location. The at symbol should be followed by the equal symbol. So here, equal sign. So right here, this is wrongly formatted because the at symbol is not in the right place. Now, this choice here, C, has the symbol at the correct location, but the argument is in the wrong place. The argument should be followed, or should follow the at symbol here. This one here is definitely wrong. It's got the at symbol definitely in the wrong location. And so that leaves us with B, which has the correct symbol at after the equal sign, followed by the parameter, followed by the function, or what the function is going to do, the operation. Okay. The next one says, what would this command do to this matrix or to this array, whatever you want to call it? And first of all, you notice that here that this statement right here is selecting all the elements of the second column, right? In other words, all the rows, second column. That's it. So it's just selecting all the elements of the second column, and it's basically deleting them because this here is is blanking that column. So it's deleting that column. And so that's the correct answer. It will delete all the elements of the second column. The next question relates to this function, which we did in one of the lectures. You notice in this function here is used to calculate the distance traveled by a freely falling object. And the function is giving you a constant gravity. So it's simply calculating this equation here, right? For different values of time. And it's giving you the distance. So by process of elimination, also we can go one by one. If you look at choice A, it says the function has one output and two inputs, and the results are written to a file called output. Well, it doesn't have an output; it has two inputs, and is not writing the results to a file called output. Output is just a variable that holds, this values here. Is not your file. It says the function writes the results of the distance, time, and acceleration to a file called results. No, it's actually going to write the values of this output, which is time and distance. The third one says calculation results are saved in fixed point notation with 8 and 10 decimal places. It does save in fixed point notation, but the .2 indicates that it uses 2 decimal places. The 8 and the 10 is the space used for each of those numbers right here. And of course, your output, time and distance are the only variables that are changing. G is not changing, right? It's just a constant. And skipping to the last one, says the function is not properly formatted and will generate an error. Well, the function's okay, is properly formatted. So that leaves us with this choice, which says the calculation results for time and distance are written to a file called results. And that's what the function does. It calculates the distance. It puts the values of time and distance into an output variable. And it creates or opens a file called results, and it's going to put the results or the output information from the function into this results file. So that's the correct answer. The next two, okay, first you're given this vector u and this vector v, and you want to perform this operation, which is the transpose of u times v. Now this was left to interpretation. I can understand that, and I think some of you may have interpreted it as a dot or point-by-point multiplication, and some didn't, and it wasn't really clear and understand that. So whether you interpreted it as a one-by-one element multiplication or just a straight matrix multiplication, either way you got credit. And if you interpret it either way, if you choose C or E, you get credit for that. As you can see, those are the only two possible choices because those are the only ones that include the transpose command in MATLAB, right? So if you chose C or D or E, you got the problem correct. Same thing for the next problem. Depending on how you interpret it, you will either see 1 as 1 or as 2. So whether you chose B or D, you also got credit, okay? The next one says, what's the code that will generate the following figure? So we have a block square in the middle of a gray square figure, right? You can also do it by process of elimination if you want, or either way. But if you go by the process of elimination, you remember that, for instance, first of all, black represents 0 represents black, and 1 represents white. So if you look at this statement right here, right, or this piece of code, 0.8 is almost white, right? So that will indicate that we will be putting a almost white figure in the middle of that square, and that's not what we want, right? So that will eliminate this in one case. At the same time, if you look at this first statement, it'll also keep the bigger square almost white, right? Because you only multiply by 0.1. So this won't give you that figure. Continuing with the next one, almost the same reasoning, right? This will give you a completely white background, right, which is not what we want here. And it'll give you, yes, it'll give you a white, almost black center. But more than that, it's got a major issue here that MATLAB won't even let you try this. Because remember, in MATLAB, there's no indexes of 0, right? So regardless of what else is going on in the other statements, this statement here will give you an error because the 0 is not going to take that 0 as an index. Okay, so that's out. Next one, same thing here. If you look at this first line, it'll give you a gray, not as great as this one, maybe a little more on the white side, but it also put a gray center. See, so you wouldn't see the difference here, right? Because it'll put a gray center of the same gray scale in the background, so it wouldn't change anything. So obviously this is the right one. You're putting a shade of white, which is the 0.8, right? And you putting a shade of black, very close to black, in the center, and so you will see that. For the next one, this one, well, basically, this is the same one we did also in the lecture. Is the same. You want to just generate yellow. So you remember colors, pixels are generated in color by assigning the red, green, and blue. Completely red is 1, absence of red is 0, and the same goes for green and blue. So a complete presence of red, green, and blue means 1, 1, 1. Complete absence of red, green, and blue means 0, 0, 0. And then any combination of those three will give you, any combination on the intensity of those numbers from 0 to 1 will give you different colors. So we can also go by elimination here, right? Well, if you look at the first one, for instance, right? First of all, you're generating a three-dimensional matrix, right, of size 200 by 200 pixels. And if you remember, this particular statement here will generate 3 matrices, each one full of zeros, 200 by 200, full just of zeros, right, including your zeros. So the first statement here will say, well, for all the elements in matrix 1 and 2, put 0.5. Okay, so that means that red and green will have 0.5. But then it goes back and says, well, no, now for 1, put back zeros again. So make that a 0 again. So this here will basically just give you green of 1/2. So some sort of green figure, right? For the next one, similar thinking. Now it says for all the matrices from 1 to 3, make them a 1. So you're combining all red, green, and blue all on 1s. But then you're changing 2 to 0. So you're combining red and blue, right? Red and blue. So that's not what you want. Because you eliminate, you put back 0 again to the green. So this will give you red plus blue. Let's go to the next one so we can see the answer at the end. This one, again, we'll put half on the green matrix and one on the uh, red one, right? So you have some red and green, but not in the amount that you want, because in order to get yellow, right, you want red and green to be one, basically. That's the only way you're gonna get the yellow that you see here. So this brings us to the answer, right, which says that matrix 1 and 2 corresponding to red and green are gonna be 1, and matrix 3, which corresponds to blue, is gonna be completely off. So you only have a combination of intensity 1s for red and green, which results in yellow. This one, very similar again. We can go over it, one by one. But again, you're generating all zeros, right, for each of the three matrices. And then you start green, because green is 2, to all ones. So that gives you the green background, because you're keeping red and blue equal to 0. You're keeping 1 and 3 equal to 0, right? But you put in ones in matrix 2, which makes it completely green. And now we do what we did in the previous example. We combine red and green on those areas. We make it a 1, and that gives you this cross right here. Okay, and the last one says, well, we have this matrix A, matrix B, matrix C, and matrix D, and you want to know what are the contents of this new matrix H when we combine the different elements here, right? So, of course, this one says that we're going to pick the first row and the third column. So the first row, third column for A is element 22. So that will be our first element. So right here, that probably will give you the answer, right? Because that will be the first element, 22. C, and then you're gonna have element 1, 2 from C. So 1, 2 from C is 18, right? And element 2, 1 from B. So 2, 1 from B, this is a column vector, right? So 2, 1 is this one right here. Second row, first column. And so that's the answer. So those are the answers to the test. And that's all I got.